welcome to lesson 2.3. We'll be solving inequalities by multiplying and dividing. So we have something extra to remember here when we're solving inequalities that require the undoing of multiplication or division. We do them like equations. We still undo multiplication with division, and we undo division with multiplication. But we have to keep one extra thing in mind. When you're using the inverse operations of multiplication and division to solve inequalities, if you multiply or divide by, and there's a reason I have that circled, that's a really important word. If you multiply, let's underline that. If you multiply or divide by a negative number, so when you're solving, if the number that you have to multiply by or divide by is negative, we have to switch around. We have to reverse the direction of the inequality symbol. If we don't remember to do that, we're going to end up with the wrong solution region and the wrong solution region shaded. Okay, so let's go to work practicing some solving here. Number 1, negative 3x is less than 27. X is being multiplied by negative 3, so we have to undo that by dividing both sides by negative 3. Take the time to write it out again, not using what was there so you don't remember what it started like. Okay? So negative 3x is going to get divided by negative 3. 27 is going to get divided by negative 3. Over here, we have x. We divided by, this is where we stop and say, what did I do? I divided by a negative, so I have to reverse the symbol, and then I say, what is 27 divided by negative 3? A positive divided by a negative is a negative, and 3 goes into 27 9 times. So there's our solution. And we will continue like we have been. We will graph these. So we have to show our integer neighbors left and right. Negative 10s to the left, negative 8 to the right. We'll put our circle at negative 9 and decide if we should include it or not. It says x has to be greater than negative 9. Not equal to is not one of the options, so we don't shade it in. We need the numbers that are greater than negative 9, so we're going to shade going to the right. Let's see if a number from that shaded region makes it true or not. Let's pick, you know what, 0 is if we kept going on the number line to the right here, we'd eventually get to 0. That's a nice number to check with. Let's do 0. We put 0 back up here in our original inequality up here, and we'd say, what's negative 3 times 0? Anything times 0 is 0. So we'd end up with 0 is less than 27. 0 is smaller than 27. It is. That's true. So feeling good about that. Now, what if we had forgotten to reverse the inequality symbol like we needed to? We would have ended up with the solution instead. You don't have to put this in your notes, but I'm just going to write it over here. We would have ended up with this solution. We'd have kept the symbol going the direction it was, and we would have said that the solution is x is less than negative 9. So then let's check to see if negative 10, which would have been, because we would have shaded to the left then, we would have needed numbers smaller than negative 9. So negative 10 would have been in our shaded region. So if we go back up here to here and put a negative 10 in up here in our original, we'd have negative 3 times negative 10, negative 3 times negative 10, negative times negative, positive 3 times 10, 30. We'd get 30 is less than 27. That's not true. 30 is not less than 27. So see, by not reversing the symbol when we were supposed to, we would have ended up with an incorrect solution region. We probably would have gotten the correct endpoint, but we would have had the wrong solution region otherwise. Okay, let's look at number 2 here. we have negative 6 is greater than or equal to 1 5/10 x, 1.5x. X is being multiplied by 1.5, so we are going to divide both sides by 1 5/10. So both sides get divided by our 1 5/10. Okay, we have a negative divided by a positive, that's negative. And how many times can we take 1.5 out of 6? Or how many times can you get $1.50 out of $6? Well, $1.50 and $1.50 added together, that's $3, and there's 2 of those in $6. So I would say we could get 4 of them out. There's $2.50s and $3. There's 2 $3 and $6. 2 times 2, 4. So we have a negative 4. Did we divide by a negative? No, we divided by a positive 1 5/10. So we don't need to reverse our symbol. And we have our x by itself. So we don't reverse the symbol because we didn't divide by a negative. Yes, we divided into a negative, but that's not the rule. The rule is by a negative. Now remember, this also, though, can be written so that if you like the variable on the left, so now we have the x and the negative 4 trade sides, and now we would reverse the symbol because we're just rewriting it, renaming it in a different format. So we didn't reverse it here because we divided by a negative, but because we were renaming it. Because sometimes that helps some of us be more successful with our graphing part. So let's get ready to graph here. Get our number line set up. Negative 5 over integer to the left, negative 3 integer neighbor to the right. So we have a circle at negative 4. It says negative 4 is greater than or equal to x. X is less than or equal to negative 4. Negative 4 is part of the solution region. If we do it using this setup, here's how we have to process that one. Negative 4 has to be greater than all of the numbers we're going to shade for x. So those numbers that are negative 4 is greater than are these guys. If we process it using this one, that one says all of the numbers you put in for x, x has to be less than, all those numbers have to be less than negative 4, which is what we just shaded. We did just shade all the numbers less than negative 4. Okay, so we really only have one solution here. It's or. Which way do you like to work with it? Okay, let's take a look at number 3 here. In number 3, we have negative 1/3 is less than x over 6. Or in other words, x divided by 6. So we look at that side where x is, and we say x is being divided by 6. That means I have to take both sides of the equation, or inequality, excuse me, times 6. Because x is being divided by 6, I undo multiplying, or division by 6 by multiplying by 6. Well, because both sides have fractions, we're going to make that 6 into a fraction also by putting it over 1. So now we have, on the left side, we have a positive 6 over 1 times a negative 1/3. So a positive times a negative is a negative. And then we can say 3 goes into itself once, goes into 6 twice. So we have 2 times 1 upstairs over 1 times 1. This becomes negative 2. I'll move that down a little bit because I'm kind of crowding out. So we have a negative 2 this side became. Did we multiply by a negative? We multiplied by 6 over 1. 6 over 1 is positive, so we do not need to reverse the inequality symbol. And now these 6's cancel out on the right side, so we have just our x. So there's our solution. Negative 2 is less than x. And remember, Or we could write it, we could have the x and the -2 trade places and flip the sign because we're renaming it. And now we can say which way do you like it? And we can graph it. So -2, -1 to the right, -3 to the left. A circle at -2. Is -2 part of the solution? No, it is not. When we read it from in the first one, it says -2 has to be smaller than, is less than, all the numbers you shade. So -2 has to be smaller than, so that would be these guys going this way. Yeah, or if we read it the other way, it should do the same thing. X has to be greater than -2. All of our shaded numbers have to be greater than -2, so those are greater than -2. Okay. And moving on to number 4. We have a -x is less than a -14. -x means really that x is being multiplied by a -1. So we're going to take -x and we're going to, we can stick a 1 in there and just show that it's really getting multiplied by a -1, so we're going to divide by a -1. Is less than a -14, and we're going to divide that by -1. Okay, now, that's x. We have to stop and say, did we multiply or divide by a negative? We divided by -1. So we did divide by a negative. We have to switch the symbol. And a -14 divided by a -1 is a +14. So there's our solution. X has to be any number greater than 14. So let's get that graphed. Is 14 included? No, x can't be 14. It has to be something greater than 14. So open circle, don't shade it in, showing it's not included, but anything past 14 going to the right is. Okay, so we have to remember that one extra thing today. When you multiply or divide by a negative number, switch the symbol around, reverse its direction. Okay, let's go to the back side. We get one more of those to practice. We have 2/3 x is greater than or equal to -3/4. So here x is being multiplied by a fraction. Remember undoing multiplying by a fraction when we were doing equations. We undo multiplying by a fraction, multiplying by the reciprocal of that fraction. So the reciprocal of 2/3 is 3/2. So we're going to multiply both sides of this inequality by 3/2. Both sides get multiplied by that, the reciprocal of what x is being multiplied by. And the reason for that is because we need those 3's to cancel, we need those 2's to cancel, we need that x to be all by itself. Did we multiply by a negative number? Is our reciprocal negative? No, it's not. It was a positive 3/2 because our fraction that it's the reciprocal of was positive. So we do not need to reverse the symbol. Can we cancel those 3's upstairs? No, one's got to be up, one's got to be down. Same thing with the 2 and the 4 downstairs. They're across from each other, not up and down, so they can work together either. So instead, what we're going to do is we're just going to multiply these fractions. We have a positive 3/2 times a negative 3/4. Positive times a negative is a negative. 3 times 3 upstairs, 9. 2 times 4 downstairs, 8. That is a improper fraction, so we're going to rename that so that we can have a better idea of where that's at in the number line. A negative 9/8 is the same as a negative 1 1/8. So that's how we want to show it so that we're going to be able to represent it well on the number line. Okay, I'm going to be really picky here. You need to show me you have good number line sense. So we're going to put negative, first of all, you know what we're going to do? Let's just decide first of all, between what two integers does negative 1 and 1/8 lie? So it would be between negative 1 and negative 2. Somewhere between those two. Those are the integer neighbors to negative 1 and 1/8. Now we have to decide where should it go between those two with good number line sense, good distance represented. So which one is it closer to? Well, negative 1 and 1/8. That means it's only negative 1 and it's only 1/8 of the way over to negative 2. So we have to be able to show negative 1 and 1/8 tick mark only 1/8 of a unit away from negative 1 on the way over to negative 2. So just to kind of help me eyeball this here, I'm going to say, you know what, there would be halfway. And then if I would cut this in half again, those would be fourths, and I need 1/8. So 1/8 is a half of a fourth, so I'm thinking negative 1 and 1/8 is right there. Negative 1 and 1/8. So this is not a 1 underneath here. I was trying to divide it in half. Okay? So I'm going to put my circle at negative 1 and 1/8. Is negative 1 and 1/8 included? Yes, it is. X can be negative 1 and 1/8. The equal to bar is there. And then it has to be anything greater than that. Those would be all the numbers going this way on the number line. So again, we have to show good number line sense. We can't just plop negative 1 and 1/8 randomly between negative 2 and negative 1. We have to show it with appropriate distance represented. Okay, we're going to do one more thing. It looks like we're going to write the inequality for this sentence, this word statement, I should say, and so we have 7 is no less than, is no less than. I see the word is in there, and I'm pretty convinced there's my inequality symbol. The quotient is the result we get when we do a division problem. That's division. And our parts for it are x and 3, and order matters in division. So 7 is no less than, So 7 is no less than. So in other words, it can be 7, or it has to be whatever 7 is no less than. So it have to be moving in the greater than. So we're going to say is greater than or equal to. 7 is no less than. So it can be 7, but it has to be it has to be greater than, moving in the greater than, because it can't be less than. The quotient of x and 3. Well, you know what? We're going to show that as a fraction because that means division also. Because those are actually easier than to show what we do to solve them. So there's our inequality setup. And now what we're going to do is we're going to solve it. So x is being divided by 3. So we're going to multiply both sides by 3. On the left side, we're not multiplying the 3 isn't being multiplied by a fraction. On the right side, there is a fraction involved, so let's put 3 over 1 on that side. So we end up with 3 times 7, 21. Is greater than or equal to, these guys cancel, we have x. Now notice I didn't stop and think for there, I have to stop and I got to go back and process. Did I multiply by a negative number? We did not, so we don't need to reverse the symbol. We can reverse the symbol if we would rather that the x is on the left and the 21 is on the right. then we can reverse it so we have our solution represented with the variable on the left side. Because what's so handy about it being on the left side is, let's get our setup here. What's so handy about it being on the left side is when the variable is on the left side, whichever way the V lying on its side is pointing tends to be, it is the way that we shade. So let's shade this one. Let's put our circle at 21. It says x is less than or equal to, so 21 is included. It's the or equal to part. Is less than, all the numbers less than 21 go this way. And notice, so it's going to the left, just like our symbol is pointing to the left. So this is kind of a little, way of double checking to see if you shaded correctly, but you can only do it that way when the variable's on the left. Can you count on that? Okay. Okay, so this takes care of what you're going to be practicing and when working with today. So good luck with it.